Hey guys, today I'm going to teach you how to apply the Pythagorean Theorem. By the end of this lesson, you'll be able to use the Pythagorean Theorem to problem solve in real-world examples. So when you got your binder, turn to the math section. Let's go ahead and take some notes. All right, so when you see a word problem about the Pythagorean Theorem, you want to break it down into an I know, I need to know, your plan, and then your solution. So we'll read the word problem together, underline anything important, and make a note of anything important in the I know box. So Bethany has a circular tabletop that she needs to carry inside her house to paint. Her front door is a rectangle and has a width of 36 inches and a height of 80 inches. If the tabletop has a diameter of 86 inches, will it fit through her front door? All right, so the first thing I know is that the front door is a 36 by 80 inch rectangle. When I'm given a description like that in words, I want to draw that as a picture. So it can be a rough sketch, and go ahead and do that in the plan and work box. Here's my quick sketch of that door, and I labeled the width and the height. I also know that the diameter is the distance all the way across the circle. So when I try to bring this circular tabletop through the door, the length all the way across it is 86 inches. So I know what you're thinking. You're probably thinking, well, of course it's not going to fit through if the height is 80 inches. However, if we turn the tabletop and go at it at a diagonal, can we bring it through that door? This is a real life problem because we have lots of furniture that is bigger than the doors in our houses, but you can manipulate it and turn it and bring it in at different angles so that it'll fit. So the last thing I know is that rectangles have 90-degree angles. Since this is a right angle, I know that this diagonal makes a right triangle. So I need to know, is that diagonal distance of the door greater than 86 inches? If I look at that as the right triangle, that red line is the hypotenuse. Since this is a Pythagorean theorem problem, I'm going to use the Pythagorean theorem's formula. A squared plus b squared equals c squared. I know that a and b are my legs. They're the two side lengths that make a right angle. So in this case, 36 and 80. So I'm going to plug in my values. 36 squared plus 80 squared will equal c squared. C being the red diagonal length of the door. Now I'm going to simplify. I get 7,696 equals c squared. Since I want to know what just c is, I need to do the inverse operation of squared. That's taking the square root of both sides. This number is not a perfect square, so the answer will end up being an irrational number. So I'm going to just round to the nearest tenth. The diagonal of the door is about 87.7 inches. I needed to know if the diagonal distance of the door would be greater than 86 inches. It is. And so I know that the table will fit through the door because its diameter of 86 inches is less than the diagonal distance of the door, 87.7 inches. Let's look at the second problem. It says Greg plays baseball at a field where the baseball diamond is a square with each side of the square measuring 90 feet. So I provided this baseball diamond for you. Each side is going to be 90 feet. And let's just go over what the bases are. Home, first, second, and third. It says if the baseball was thrown from a home plate to second base, and then from second base to third base, how many feet did the baseball travel? Round to the nearest tenth. All right, so the first thing I know is that a square has equal sides and 90-degree angles. So I know that the distance between second and third base is 90 feet because it's a square and each side measures 90 feet. I don't know this diagonal distance, but I do know that I can use the Pythagorean theorem to find the diagonal distance from home to second because this makes a right triangle. The right angle would be right here or here if you look at it from the other side. I need to know how many feet the baseball traveled altogether. So I need to know the sum of the diagonal distance and the one side of the square. In other words, what I drew in yellow. Since I know I'm using the Pythagorean theorem, I want to go ahead and write that out. A squared plus b squared equals c squared, where a and b are legs of the right triangle. The legs make the 90-degree angle. So in this case, 90 and 90 are my legs. So I'll substitute those values. Should have 90 squared plus 90 squared equals c squared, and then I can simplify. You should get 16,200 equals c squared. I want to know what just c equals, so I need to get rid of that squared. So I'm going to do the inverse operation of squared, which is to take the square root of both sides. Since the square root of 16,200 is an irrational number, I'm going to round to the nearest tenth, and I got 127.3 is the length of the diagonal. The question was asking me for the sum of the diagonal distance and one side of the square, since the baseball was thrown from home to second and then from second to third. So I need to add on that 90 feet distance. So I know that in total, the baseball traveled 217.3 feet. All right, so for the next 6 problems, you're not going to have those I know, I need to know, plan and work, and solution boxes. So off to the side on a separate sheet of paper, I want you to keep track of your work in the same way. Make sure that you're attacking these problems strategically. So what we're going to do is I'm going to have you try 3, 4, and 5 by yourself. When you press play, the answers will appear. So try all three problems by yourself and press play when you're ready to check all three problems. All right, so here's your answers for this section. If you got these right, you can skip ahead. If not, stay with me and we'll go over each one of these. So number 3 says Melissa wants to put a ribbon border around a sign in her classroom that's shaped like a right triangle. If ribbon costs 82 cents per foot, how much will it cost her to buy the ribbon for her sign? So since this is a right triangle, I know that 6 and 8 are the legs of the right triangle because they make the right angle. I know that I need to find the length of the hypotenuse, or C, because Melissa wants to put the border around the whole sign. So I know I'm going to use the Pythagorean Theorem, a squared plus b squared equals c squared, and I'm going to substitute in my values. 6 squared plus 8 squared equals c squared. Now I'm going to simplify. 100 equals c squared. I want to know what c is, so I need to use an inverse operation for squared. That's to take the square root. I know that 10 times 10 is 100, so 10 is the length of c. Since Melissa wants to put a ribbon border around the whole sign, I need to find the perimeter of this right triangle. So I'm going to add up 6, 8, and 10, which means that there is 24 feet in total. I also know that each ribbon costs 82 cents per foot. Since it's 82 cents per foot, I'm going to multiply the amount of feet by that 82 cents. That's going to give me the total price of $19.68. In number 4, I'm looking at an isosceles triangle. I know in an isosceles triangle, two sides are the same length. In this case, these are the two sides, and each side measures 13 meters. The base of the triangle is 10 meters, so you can see where this height cuts it in half. The base here and the base here would each be 5, because that makes 10. When I do that, it makes two right triangles, and I want to know what's the height of this triangle. So my plan is going to be to use the Pythagorean theorem to solve for the missing height. Only this time, the height is one of the legs. So just be careful about that when you're substituting in your values. I know that 5 squared plus the missing height, b squared, you could have put that as a squared, it's up to you, as long as you put the hypotenuse, c, as 13 squared. Now I'm going to simplify, and I need to solve for b. So I'm going to start by drawing my line on the equals, and I'm going to undo what's being done to b. So I need to get rid of the plus 25 with the minus 25, and I'm left with b squared equals 144. I know that if I take the square root of both sides, then I would end up with a height of 12 meters. In number 5, I'm looking at a square sandbox in Trisha's backyard with an area of 81 square feet. I'm going to need to find x, the diagonal length of the sandbox. I know that a square has all sides that are equal, and the formula for area of a square is length times width, or base times height. So that needs to be the same number. So I can take the square root of 81 to find the length of one of those sides. The square root of 81 is 9. So I know this is a 9 by 9 square. So each one of these sides is 9 feet. I know that all squares have right angles, and when a diagonal cuts through that square, it turns it into two right triangles. Since I want to know this diagonal distance, I'm going to use the Pythagorean theorem. So I know the Pythagorean theorem is a squared plus b squared equals c squared. Now I need to plug in my values. A and b are the legs of the right triangle, and the legs make the right angle. So a and b are 9 and 9. Now I can simplify. I know 9 squared is 81, and 81 plus 81 is 162. Now I need to know what c is, not c squared. So I take the square root of both sides, and I end up with c is approximately 12.7 feet when I round to the nearest tenth. Now let's try the next three problems again by yourself. Pause the video now to try all three, and then press play when you're ready to check. All right, so here's your answers for 6, 7, and 8. If you got all three correct and you have no questions, then you can skip ahead to the end and finish for today. If not, stick with me and we'll go over. So number 6, it says to walk to her friend's house, Julie normally walks 63 yards north and 16 yards east as shown in this picture. What we want to know is how many yards shorter would it be if Julie took the diagonal shortcut x. So I know that this distance here makes a right angle. And when we're looking for the diagonal length, we're really looking for the hypotenuse. It makes a right triangle. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for this distance. So let's plug in our values. A and b are the legs of the right triangle, and the legs make the right angle. So I'm going to substitute in 63 and 16 for a and b. Doesn't matter which order you put them in. Now I'm going to simplify. I know c squared equals 4,225, and I want to know what just c equals. So the inverse operation for squared is to take the square root of both sides. Since the hypotenuse is 65, x is 65. But the question wasn't just asking me to find the diagonal shortcut. The question was asking me, how many yards shorter would it be if we took the diagonal shortcut? Since Julie normally walks 63 yards north, and 16 yards east, she walks a total of 79 yards to get to her friend's house. But the shortcut is 65 yards. And if I want to know the distance between them or how many yards shorter, I'm going to want to subtract. 79 minus 65 gives me 14 yards difference. Let's look at number 7. It says if the perimeter of square 3 is 36 units and the perimeter of square 2 is 48 units, what is the area of square 1? So I know a few things. I know that in a square, all the sides are equal. I also know that perimeter means all the sides added up. Since there's 4 equal sides, I can take square 3's perimeter of 36 units and divide it by 4 to get the length of one side. So I know that the length of one side is 9. And the reason I want to do that is because I need to end up finding out the area of square 1. I know that the area of a square is length times width. I don't know this length, so I'm going to find it by using the Pythagorean theorem. So I need the lengths of all these other sides. So we're going to find the length of square 2 the same way. The length of one side is going to be 48 divided by 4, since there's a perimeter of 48 and there's 4 equal sides. Each side is worth 12 units. Now this makes a right triangle. It has 2 legs of 9 and 12 because they make the right angle. I need to find the hypotenuse, the red line, because that's one side of the square. If I know the side of square 1, I know the area of square 1. So we're going to use the Pythagorean theorem to solve for the missing side. In this case, it's the hypotenuse. So I'm going to plug in my values. I have 9 squared plus 12 squared equals c squared. Now I'm going to simplify. I get 225 equals c squared. That is the area of square 1. So that's my final answer. But if you weren't sure and you wanted to do the extra step, you would just be taking one extra step to do it. You take the square root of both sides. You'd realize that one side of the red square is 15 units. And you know that the area of the square, which is what you're trying to find, is 15 times 15, which would get you back to 225 square units. All right, last question, number 8. Lincoln is building a wooden garage door in the shape of a rectangle with a width of 16 feet and a height of 8 feet. Lincoln is going to place 2 boards in the shape of an X on the door. How many feet of materials will he need for the X? I know that a rectangle is made up of 90-degree angles. So the height of 8 and the width of 16 make a right angle. I know that I'm finding the X, which is a diagonal of that rectangle. This makes a right triangle, where I'm given the lengths of 2 of the legs, since they make the right angle. So I'm going to use the Pythagorean theorem and substitute in my values. 8 squared plus 16 squared will equal c squared. Now I'm going to simplify, and I get 320 equals c squared. I want to know what just c equals, so I need to do the inverse operation of squared, which is to take the square root of both sides. You'll get approximately 17.8 or 17.9 feet for the length of one of these diagonals. Since you want to know what the whole x would be, we're going to multiply that number by 2. That gets us approximately 35.8 feet. If you're off by a tenth, that's okay. All right, guys, that's it. If you made it to the end of this video, please comment your favorite sport. Mine is swimming. Today we did some practice applying the Pythagorean theorem. So now you should be able to use the Pythagorean theorem to problem solve in real-world examples. Now go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!